Tutor, and today we're going to be talking about energy transfers by heat with conduction, evaporation, and convection. First of all, conduction. Now, conduction only occurs in solids. Why? Well, let's look here. This is a solid, this is a liquid, this is a gas. These solid particles are tightly packed together, and so they are very dense, and they only vibrate. They cannot move. They're too tightly packed together, so they cannot move. So they transfer energy through their vibrations. Okay, and we know that all particles, when they collide, they transfer energy. And because in the solid, the particles are always tightly packed together, and they're frequently colliding with each other because they're so tightly packed together, they're going to be transferring energy very easily through conduction. And so, the collisions are very frequent. So if we heat one end of the solid, we're giving it energy in the form of heat energy. And so they have this now kinetic energy, and they start vibrating more. And the particles here, which are vibrating more, so here's the heat source, these particles start vibrating more, and then they collide with these particles, transferring their energy. So they collide more, they vibrate more, they vibrate more, and they vibrate more. Let me give you an example. Okay, so imagine each of these dominoes is a particle, and they are all vibrating, all of them, but very slowly. So they have some kinetic energy. Now, if I start heating one end of the solid, say my finger is a heat source, it will start vibrating more and more and more. And because they're so close together, they can easily transfer their energy through collisions and vibrations. Watch. See how quickly the energy was transferred? And this is especially the case in metals. Why? I'll talk about that now. Okay. So metals, like any other solid, transfer energy through conduction because of the particles are tightly packed together. So they transfer energy the same way as other solids. But metals are special because they have things called electrons. But all atoms have electrons. Everything has electrons. But metals, they have free electrons. Free electrons, or you could say delocalized electrons. And these free electrons, the thing that's good about them is they can move. But not just move, they can move through the structure. So they can move through the metal. And the thing about electrons is they can carry energy. And because they can carry energy, they can therefore transfer energy. So metals have free electrons which can move through the metallic structure, and because they can carry energy, they can transfer the energy. And so energy is transferred by conduction much faster in metals. Now we're going to move on to convection. Okay, so convection. Now convection, unlike conduction, only occurs in fluids. So that means gases and liquids. Many students think conduction only happens in liquids or in gases, and so they lose marks in the exam. It happens in gases and liquids because gases and liquids can flow. Okay, the gas here is flowing. Okay, this liquid here is going to flow into my mouth. But solids, they cannot flow. It's not flowing. So here we have a liquid, here we have a gas. We see in a liquid and a gas, the particles are not tightly packed together. Okay? They have space. Okay? They are spread out. And so they can move. The particles can move. They do not just vibrate. Obviously in a liquid though, the particles are not as spread out as in a gas. And so gas particles have more energy. And because they have more energy, they can move more rapidly. They can move quickly. And obviously, they're very spread out. And they are very, they're not dense. They're less dense. Liquids, they're more dense than solids. They're less dense than solids, but more dense than gases. Okay, they are spread out, but not as much as gases. Okay, I'm being too verbose now. Let us move on to the actual idea of convection. Okay, so convection. Convection is based on the idea that heat rises and cold sinks. So warm air rises and cold air sinks. Here we have the example of air. Here we have a flame. The flame is the heat source. And the air above the flame is rising. Why is it rising? Because the particles are becoming more spread out, and so the gas particles are now less dense. Why? Because they have more energy given to them by the heat. Okay, they now have more kinetic energy to move more, and so they become more spread out and less dense, so they rise. As they go away from the heat source, they obviously cool down, and because they cool down, they lose energy, and so they become more dense, less spread out, and so they sink. Okay, and cold air always comes down to replace hot air. So then here's hot air, and then here's a cold air coming down to replace it. Okay, this is what we call a convection current. Now we're going to look at convection and liquids. Okay, so convection and liquids. Here we have a circular or ovular tube, an oval-shaped tube, or whatever. Okay, you've got a tube here with water, and here you have a flame. Now the flame is going to heat up this part of the liquid, and so this part of the liquid, they have more energy, so they move more, and so they are less dense because they are more spread out, and because of this it rises, and then as it goes here, obviously just moves along, and now it loses its energy because now it's away from the heat source, so then less energy, and because they have less energy they move less, and so they become more closer together, so they are less spread out, so they become more dense and sinks. And obviously then it moves along here, and then the whole process starts again. Here we have a convection current. Okay, so let's look at the liquid particles here and the liquid particles there. Liquid particles here, as they're gaining the heat, they become more spread out. Okay, but the liquid particles here now, they're away from the heat source, they have less energy, so they become close together, more dense, so they look more like this. So they sink, and then the process starts again. Convection current. Now we're going to look at evaporation. Okay, evaporation. Now evaporation is when a liquid becomes a gas. Okay, so if you heat something, it will evaporate. But students usually forget this. You don't need heat for evaporation to occur. You don't need external heat. Like, you don't need to heat something up. You don't need to give it more energy for it to evaporate. Okay? Here's an example. Here's the liquid. This is the surface of the liquid. Now we know that particles are attracted to each other. That's what keeps them together. But some particles in the liquid, not all of them, some have enough energy to escape the surface. Okay, so some particles, they have enough energy to escape the surface. And therefore they become a gas. And by definition, liquid to gas, they have evaporated. Not the whole liquid, just that one particle or several particles. And that is how hot drinks become cold. Because particles, we know that they carry energy. So if one particle escapes, it carries that energy with it. And so you are losing energy as each particle escapes. Okay? Think of this example. I'm having a party. And considering the guests come, each guest will represent a particle. Now usually, parties who have that have more guests are more wild, they're more fun, more energy. But as guests start leaving, the energy of the party decreases. It becomes less fun, less wild. Okay? And so the overall party has less energy. Okay, so the overall liquid now has less energy because some of its particles are escaping with some of its energy. Or you can think of it as like a bank. You know, the particle is leaving the bank with the bank's own money. And so the bank is losing money overall. Okay, you can use lots of examples. Okay, but the main thing is, as particles escape, they carry energy, so the whole thing overall loses some energy. Now I'm going to look at just one more thing. So evaporation, there are some conditions which make evaporation happen faster. Obviously the most obvious one is heat. Okay, the hotter an object is, the more easy it evaporates. That's why if you heat something, it evaporates very quickly. Obviously we also have dry conditions and windy conditions. All these conditions make evaporation happen faster. Now sweating is a really good example of evaporation. Okay, if you're out on a hot day or you're exercising, your internal body temperature increases, and you need to keep that body temperature constant in order to keep your body functioning properly. I'm not going to go into too much detail about that because that's biology. So what happens to keep your body temperature constant is you sweat, and sweat is a liquid, of course. So the energy from your body, it is transferred to the sweat. And so your body itself loses energy in the form of heat, so it becomes cooler. And the sweat now has enough energy to evaporate. So the main thing you should take away from this is evaporation cools substances down. This has been the Awesome Tutor. Bye.